Hello, everybody. This is James and Debbie from Group 15 in Augmenting Human Dexterity. And for our final project, we are working with enhancing eating utensils.
Our need knower is a woman in her late 20s. She is on the autism spectrum and has cerebral palsy. We interviewed her along with her mother and caretaker. During the interview, we discussed how independently eating is important for a need knower and barriers to successfully independently eat by herself. Next slide. What is cerebral palsy? Cerebral palsy affects people differently. It is a group of neurological disorders that affects a person's motor skills, such as body movement, muscle coordination, and balance. For our need knower, cerebral palsy impacts how she consumes food and completes dexterous tasks. Our need knower values eating and drinking independently because it brings her joy. Next slide.
All right, so for our device, we came up with a utensil handle attachment, which will effectively notify the user if they're eating too fast or if their food is too hot. And it does that through a temperature sensor and also an accelerometer, as well as a vibration motor. So the vibration is the main method we're using to notify the user of the food being too hot or if they're eating too fast. And this is all kind of brought together with the microcontroller that runs a finite state machine. And that is all brought together with a cylindrical 3D printed casing housing that functions as the handle of the spoon. And next we will demo our device.
So the device is connected to the laptop, and on the serial monitor on the left we can see the acceleration values. Next to it is the move count, which is an incremental mechanism in the code where if it reaches a certain threshold, the user is deemed to be moving too fast. Next is the current state of the device, and next to that is the temperature in Fahrenheit, and then the next three are the temperature status, movement status, and vibration statuses of the device. And so if we take the device and move it very rapidly as if we were eating very fast, it will start to vibrate. And if we zoom into the code right here, vibration status will be vibrating, it will be too fast, and the state will be 1. And if we stop, it will go back to the previous state. And if we place it in a hot environment, like this hot pot of water, it will start to sense the change in temperature. And eventually, once it reaches a certain temperature threshold, it will start vibrating again due to the temperature. And this threshold can be changed depending on the situation, and also this temperature sensing could be improved as well with the method with less temperature delay. And so now it is now vibrating because the temperature threshold has been reached. Thank you for watching this demo.
All right. Thank you, everybody, for watching our presentation, and special thanks to Professor Hannah Stewart and Giasai Dehilamun for their help. Thank you.